Hello everyone, this is Mr. Mitchell with 10 minutes on 9.1 note-taking, vocabulary, and practice. It'll be mostly practice. First off, if you go into your Schoology Assignments and Office Hours updated last night, I should update this again here soon, you'll see assignments in here for the week. There'll be more detail put in here. And you can see that goes on for an outline for the rest of the school year, though we're not sure what's up with finals week. You will see when you're in your regular materials, assignments listed out over here on the side in a second. You can always click on those for more detail as to what is in each individual assignment. It will be in there. I'll try to get them in that other document here soon too. We got page numbers on some of these terms up here. You can go to those pages, read your text. It is good to practice reading that, build up that vocabulary so you can read through it. Fill in the blanks right there. You'll see that for a few of these in here. I added at the bottom radicand down here. They mentioned that in both simplest form and like radicals, but it wasn't in the vocab. It is something that you need to know. I have added to the notes down here quite a bit. I color-coded some of this so you can see the parts different. What they're doing here, root 9 times root 5, that's because they're thinking 45 is multiplying to that. The index on this is 2 also. Remember, a square root, we assume the index is 2. I mentioned why we chose root 9 times 5. We have all these numbers that multiply to 45, but the only perfect square we had in there was 9. Now down here you want to fill out these perfect squares. The squares are your perfect squares. 1 squared is 1. We don't use that one there yet. So 3 squared is 9, so 9 is a perfect square. 6 squared is 36, that's a perfect square. 18 squared is 324, that's a perfect square. These are numbers you need to know. You will not get full credit on problems without showing the work and the steps you use to break them down. You do have a few to complete here. 4 squared, you should know that is 16. 5 squared, you should know what that is. What number squared is 196? Well, if this is 13 squared and that's 15 squared, I think you can figure it out. And then just complete the rest of these blanks. I have some examples here for you. So on one of these, I forgot to circle the answer, so let's circle the answer there and get that in there. As always, these examples are from your MPs on page 480 in your book. There are a couple more for you to try there. There are videos that go along with those. I wrote out some steps. You do have to be good with your arithmetic here. This is going to be challenging at times. Radicals and fractions, how we break them up here. If it's all under the radical, you can break it into 2 radicals. I took the square root of the denominator, though I made a mistake down here. So you get square root of 23 over 3. On number 10, I broke it into the parts. I could take a cube root. I chose the cube root here. You don't have to do the cube root ones later, but you know the cube root of 8 is 2. The cube root of x cubed is just x. I couldn't take a cube root of these, so I broke that into 2 parts up there. Again, this one is more like number 5 over there. I could do a cube root of 27. This is called rationalizing the denominator. This is where you multiply by a fraction that's equal to 1. Root 2x over root 2x is 1. Root 2x times root 2x gives me square root of 4x squared, which is just 2x. Rationalizing the denominator, no square root in the denominator. That's one of our terms we saw earlier. Now, to get into the problems here. Square root of 24. Now, I'm not going to do this the long way. Okay, I think we were about to start this problems when I left off a second ago. I realized we didn't have our answers in. Now, when you do this, there's a few different ways we look at this. At 24, you got to be able to look at these numbers and recognize everything that multiplies to them. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Well, when I look at all these numbers, I only see one of our perfect squares. A lot of times you'll see more than one. If you see more than one, you want to pick the bigger one. I see right here the 4. Okay? And I'm going to use that one. So I'm going to break, 24. That's root 4 times root 6. Remember, if I have 4 times 6 under the square root, I can break it up. The square root of 4 is just 2. So I end up with 2 root 6, and that is done. Now, some of these are going to be a little bit bigger. Some of them will take more than one step. 512, that's pretty tough to get every number that multiplies to that. But hey, it's an even number, and I'm going to divide that out on my calculator, and I find out pretty quick that 4 times, what was it, I forget here now, 128. 4 times 128 gives me my 512. So that might not be the best way to go about it, but it's a quick one, so I'm going to use that. So I'm going to get a negative. I'm going to get a square root, and I'm going to have 4 because I can take the square root of 4. Now h to the 7 is odd. I can't take the square root of an odd number. I can take the square root of an even exponent. So I'm just going to cut one off of that, and I'm going to take h to the 6th. And then in my second square root, I'm going to get the 128, because 4 times 128 gives me 512. And I'm going to have an h, because h to the 6th times h to the 7th, or h to the 6th times h gives us h to the 7th. Now this is going to be negative 2h cubed times 128. Well, 128, I can still take the square root of that. Now, hey, I'm getting a little bit better with 128. I can list out all my 128s. I got 1 times 128, 2 times 64. Hey, I recognize 64. 3 doesn't go in there. 4 times 32. 5 doesn't go in. 6 doesn't go in. 7 doesn't go in. 8 times 16. And I don't think we have anything else there. So I'm going to do my 64 times 2. I see a 64, I see a 4, I see a 16, so I got a bunch of square roots in there. I'm going to pick the biggest one because it's fewer steps. I'd have to do more of these square root steps again. So this is going to be square root of 64 times square root of 2h. So that's negative 2h cubed times 8 times square root of 2h. Negative 2 times 8, that's negative 16 cubed times 2h. See it over here. I got this one right. I forgot to check this one. 2 root 6. I see it right there. So that one's looking good. Number 7. Down here, I can break this up too. I can go square root of 196. Oops, get my negative out front. Over square root of r to the 4th. Well, 196, that's just one of our perfect squares that we had up here. 196, that's 14 from our missing pattern there. So that's just going to, oops, that's my negative sign, not an equals. So that's just going to be negative 14. Well, r to the 4th is just r squared squared. So half of that, you know, if you think of it, square root of r squared squared, these cancel out. We're left with r squared. Remember, it's half of that even exponent. There's our answer, negative 14 over r squared. I see it up there. 9 to 12 are optional using these cube roots. You can try those. Search them online if you want to take a look for that. We're running slow on our example. A couple of different ways to approach these fractions. More often than not, there's more than 1 or 2 ways. I'm going to show you a couple of different ways on 13 and 15. On 13, I'm seeing, oh, you know what, 500, I see square root of 15. I see a square root of 100 there, which I can easily take a square root of over 3. Now, since both 15 and 3 are under square roots, I can reduce those. That's just going to go to, oops, that's not a 3 there, that should be a 5. But 5 goes into 15, I can reduce that. In 15 it goes to 3, that goes to 1. So I'm going to have square root of 3. Square root of 100 is 10. Square root of 1 is 1 times 1. I don't really need square root of 1. That's just root 3 over 10. Oops, there's my answer. It checks out. So this one I broke it up. This one I got a lot of stuff here. You know what? I'm going to reduce some of this stuff out right away and simplify it so I get to look at less. These y cubes cancel out right away. They're both under the root. I can cancel them out. That goes to 1. This x and the x squared will go to one of the x's. That x cancels with one of those. I'm going to use some slightly thinner pens on this for a second. So that goes, that goes, that goes, that goes to 1. So I have square root of 3x over, I forgot my y cubed went 2, I don't know what happened to that, over square root of 80. Square root of 80, you can list out all those factors if you want. I always start 1 times 80, 2 times 40 and go through it. I see right away here I got a 5 times 16 or a 16 times 5. I'm going to use that one, so that's going to be square root of 3x over square root of 16 times square root of 5. That's going to give me square root of 3x over 4 root 5. Well, I can't have that square root in the denominator. That's where I have to rationalize the denominator. I got to multiply by 1. Whatever that square root in the denominator is, square root of 5 over square root of 5, multiply by itself over itself, is equal to 1. That's going to give us in the top 15x as the radicand. This is going to be 4 times root 25. But you should start to notice a pattern on these. That's just going to be 5. So that's going to be 15x over 4 times 5, which is square root of 15x all over 20. And there's that answer over there, and we're looking good. 17 to 20 we're skipping. Sorry for this running a little long. There's a lot of problems in here. 21, golden ratio, length to width ratios, length to width, length to width, length to width. So that's going to be 1 plus square root of 5 over 2. So the length is in the top, the width is in the bottom. That's going to be 62 over x. You can cross multiply and solve that. In fact, just skip that one. Don't worry about it. Skip it. It's going to require some of that 17 to 20 work. These ones down here, it's just multiple simplifications. So you're going to reduce this. Oh, 18. That's just 2 times root 9 times root 2. That's 2 times 3 root 2. That gives me 6 root 2. I can simplify this one here too. That's going to be minus 2 square root of 5 times square root of, whoops, I got that backwards, square root of 4 square root of 5. So that's minus 2 times 2 root 5. So that's going to be minus 4 root 5. And then I have minus 2 root 5 here at the end. Well, I do have some like terms. Root 5 and root 5 are like terms. I can subtract those. Negative 4 root 5 minus 2 root 5, that's going to be negative 6 root 5. And then I have this 6 root here too in front. And there's my answer. Oh, they got it turned around over here. That's fine. I guess they like those bigger square roots first. So that's just going to go into negative 6 root 5 plus 6 root 2. And there's our answer, and it checks out with what we got over there. Sorry this went a little bit more than 10 minutes today. Have a good day. Thanks for tuning in.